With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. So question says this: the vapor pressure of pure CS2, right? So the vapor pressure of pure CS2 and CS3COCS3, that is acetone, are 512 mm of Hg and 312 mm of Hg respectively, right? So the total vapor pressure of the mixture is 600 mm of Hg, right? So then find out the incorrect statement, right? So we have to tell the incorrect statement, right? So let's start solving this question, right? So we have pure CS2, right? So I can write here, we have pure CS2. Right, we have pure CS2 and acetone, right? So I can write here as we have pure CS2 and acetone, right? Acetone, which have a formula CH3 CO CH3, right? So when this as pure CH2 and acetone are mixed together, so they will form a non-ideal solution, right? Because in case of non-ideal solution, nothing will be zero, nothing will not equal to zero, right? So here, in case of non-ideal solution, I can write here as in case of non-ideal solution, right? So in case of non-ideal solution, the delta H, right? So the delta H mixing, right? So the delta H mixing not equal to zero. It may be equal, either it will be greater than zero or less than zero, but it is not equal to zero, right? And delta V mixing, right? And delta V mixing, right? So this is delta V mixing, right? So I can write here as delta mixing, right? V, right? So this is delta V mixing, V not equal to zero, right? So it may be greater than zero or less than zero, but it is not equal to zero, right? So this can be proved from the question, right? So because we have gain the total vapor pressure of the mixture is 600 mm of Hg, right? So that means I can say this: the vapor pressure of pure CS2 is 512, right? So the 512 mm of Hg, right? So 512 mm of Hg, right? And the vapor pressure of acetone, right? So that is 312, right? So that is 312 mm of Hg, right? And when these two solutions, or you can say when these two individual constituents mix together, they will form a solution having the total vapor pressure, right? The total vapor pressure will be equals to, right? So I can say this: the total vapor pressure is equals to 600, right? So is equals to 600 mm of Hg, right? So 600 mm of Hg, right? Right. So you can see here the total vapor pressure is greater than their individual constituent of the vapor pressure, right? So that means the they are forming the non-ideal solution, right? So they are forming the non-ideal solution, right? And we know that the non-ideal solution are two types, right? So I can say this: the non-ideal solution, right? So I can write here as the non-ideal solution non-ideal solution having two types, right? So one is a positive deviation, right? So one is the positive deviation from the Rolle's law, right? So I can say this solution which is showing the positive deviation, right? So the solution which is showing the positive deviation, right? That is positive deviation from the Rolle's law, and a solution which is showing the negative deviation from the Rolle's law, right? So I can write here as negative deviation from the Rolle's law. That means the non-ideal solution do not obey the Rolle's law, right? So either will they show a positive deviation or either will they show negative deviation, right? So either will they show positive deviation and either will they show negative deviation, right? So now what happened actually in positive deviation? In positive deviation, you can see here in positive deviation the delta H mixing, right? So delta H mixing, right? So the delta H mixing will be, or you can say, greater than zero, right? And delta V mixing, right? So delta V mixing, that means volume, right? So will be greater than zero, right? Will be greater than zero, right? But in the case of negative deviation, but this is not equal to zero, right? So they are greater than zero, right? So in case of positive deviation, that's why it is called positive deviation, right? But in case of negative deviation, the delta H mixing, right? So I can write here as the delta H mixing, right? So this is a delta H mixing, right? Delta H mixing is less than zero, and similarly the delta V mixing, right? So this is delta V mixing. I can write here as the enthalpy, there is a volume change, is less than zero, right? So this means that here you can see here, right? So here you can see here the delta H mixing is greater than zero. That means the enthalpy change is positive, right? So the enthalpy change is positive. It means they are showing the endothermic solution, right? So I can see here from, I can write here from, the solution is endothermic, right? So I can write here the solution is endothermic, right? So solution is endothermic, right? So this is endothermic. So this is endothermic. I can write it clearly. So this is endothermic, endothermic, right? Is because we are obtaining the enthalpy change is positive, right? So which is greater than 0, right? And here you can see here, in case of positive deviation, the delta V mixing is greater than 0, right? So delta V mixing is greater than 0, right? So, and one more thing is that in case of positive deviation, right? In case of positive deviation, the attraction or the interaction between the constituent of the individual constituent is greater than their solution, right? So I can write here if there are two constituents, right? So if there are two constituents, let's say this is A constituent and this is B constituent, their individual attraction is greater than their, you can say that their two A and B interaction, right? So this is the interaction between A and B, and this is the interaction between the two individual constituent, right? So this attraction or interaction will be greater than, right, in case of positive deviation, right? But in case of negative deviation, this will be reverse, right? So now let's check the option. Option A says that the attraction or the interaction between the A and B is more as compared to AB, right? So this means this is showing a, you can say this is kind of showing a right answer, right? Because this is case of positive deviation, right? So this is case of positive deviation in the non-ideal solution, right? So this statement seems to be correct, right? So this is a very correct statement, right? And they does not obey the Rolle's law, right? And we know that the non-ideal solution, right? So the non-ideal solution does not obey the Rolle's law, right? So I can write here does not obey Rolle's law, right? So the non-ideal solution does not obey Rolle's law, right? So either will they say positive deviation or they will show negative deviation, right? So they will show positive deviation, right? And they will show negative deviation, right? So this statement is correct, right? And the option C is it is endothermic solution, right? So yes, it is a kind of endothermic solution because we are obtaining a delta H mixing is greater than 0, right? So we are obtaining a delta H mixing is greater than 0. That means it is endothermic, right? So energy is absorbed, right? So and in case of option D, after adding 100 ml of each, then the net volume is less than 2 ml, right? Not 2 ml, it is 200 ml, right? So this means that I can write here, this means that if I am adding the A constant, that is our CS2, right? So this is our CS2, right? And this another constituent, that is acetone, that is CS3, COCS3, right? So when we add it, right? So 100 ml, let's say this 100 ml, and let's say this is 100 ml, right? This is 100 ml, right? So when we add this, the solution, the volume of the solution should be, or you can say 200 ml, right? Should be 200 ml, right? Should be 200 ml, right? But in case of positive deviation, the delta V mixing, right? So here you can see here, this is the volume, right? But the volume mixing, right? So the change in the volume mixing will be the change in the volume mixing, right? So here I can say that the change in the volume mixing will be greater than, right? So will be greater than 0, right? In this case, this because we are taking the particular example of CS2 and acetone. In this case, the volume change of mixing is greater than 0. But in the question, it is saying that after adding 100 ml of it, the net volume is less than 200 ml. That means, so it is not a right answer, right? Because it is not right statement, right? Because here you can see here you are saying that in this question, the question is saying that here we are getting the delta V mixing is less than 0, right? Delta V mixing is less than 0, but this is not the case, right? So here the correct statement should be the after adding the 100 ml of each, the net volume will be greater than or equal to 200 ml, right? So this is the case of positive deviation, right? But this becomes the case of negative deviation, right? So in this way, I can say this, and we know that the solution of CS2 and acetone will make an node ideal solution and will show a positive deviation, right? So, but this is a case of negative deviation. So in this way, I can say this: the option D will be the correct answer, and this statement is the wrong statement, right? This statement is the wrong statement, right? So this statement will become correct if here it is written that is more than 200 ml, right? So this becomes correct, right? But here it is written as the net volume is less than 200 ml, right? So this statement becomes incorrect, right? So now we are left with the correct answer, that is option D, right? Because this is a incorrect statement, and rest of the statement are correct statement, right? So the incorrect statement will be our right answer, right? So hope this answered your question, and so thank you. And along with this, option A, B, and C will be the wrong answer, and option D will be the right answer, right? So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.